All right, Algebra 2, Lesson 8, the last lesson in Unit 2. We're going to talk about piecewise functions. So piecewise functions are basically at least two functions, okay? So there are at least two functions where the different functions apply to different parts of the domain. So we can look at, say, an example. Let's say, okay, this is a piecewise function. And if x is less than or equal to 1, I'm going to use this function right here because x is less than or equal to 1. If x is greater than 1, I'm going to use this function. So again, we have to determine what is our x values. Again, x is your domain. And then that will determine which function we use to calculate it. So if I were to say, all right, I want to find when x equals 1, and I want to find when x equals 5. So when x equals 1, I know that because it says x is less than or equal to, I'm going to use the top function. So g of 1 equals 2 times 1 minus 1. 2 minus 1 equals 2 minus 1 is 1, Mr. Larson. 1. So g of 1 equals 1. However, if I wanted to find 5, so g of 5, I would have to use my bottom function. So every time I see an x, I'm going to plug in a 5. 15 plus 1. So g of 5 equals 16. So again, you have to determine what is your domain, what x value are you using, and that's going to tell you which function you need to use. So let's look at a graph of a piecewise function. So if I have something that looks like this, and my functions are going to be f of x equals negative 3 over 2 x minus 1 if x is less than 2. If x is less than 2. X plus 1 if x is in between negative 2 and positive 1. This is going to be negative 2 if x is less than negative 2. And then it's just going to be 3 if x is greater than 1. Again, we've got to cover all parts of our domain. So notice, I didn't write this one correctly. Notice we've got or equal to here, and we do not have or equal to on these ones. And that will come into play when we graph it. So let's see here. 2, 4, 1, 2, 3, 4. Okay. So when x is less than negative 2, so negative 1, negative 2, negative 3, I'm going to start at here. I'm going to use an open circle because it does not equal to. So I'm going to use an open circle, and then my slope is negative 3, 2. So 3 over 2. And I would draw my line like that. Now I'm going to graph my second equation, but because it is it's or equal to, I'm going to have to use a open circle. So I know that my y-intercept is 1 and my slope is just 1. So it's going to be something like this. And I need to use a closed circle because it's or equal to. And then this one is also going to be a closed circle because it's or equal to on both sides. And then when x is greater than 1, y is 3. So that's just going to be a flat line like that. So again, the parts, I'll highlight it. Let's see here. Yellow is going to be my first graph right here. Orange will be my second one, which is right here. Again, notice the closed circles on the ends. And then when x is greater than 1, it is this graph right here. So let's look ahead and maybe say, all right, let's say you got this picture. Could you write a piecewise function? So if this is my graph, could you write a piecewise function from the graph? Of course you can. So I'm going to say, okay, when x is in between 0 and 1, it's 1. But again, I have to pay attention to my closed circles and open circles. So x can be 0, but it cannot be 1 because it jumps up to 2. When x is 1, it jumps up to 2. So when x is 2, or when x is 1, again, I have to have 1 greater than or equal to, and then 1 just, I guess it was a less than symbol. 1 is less than or equal to x, which is less than 2. And again, notice when it jumps up, when it hits 2, it jumps up here. And then when x is 3, again, very similar. This is called a step function. So again, there's like levels. From 0 to 1, or 0 to 0.9999999, it's 1. And then as soon as it hit 1, it steps up. It jumps up. So this is an example of a step function. And this is like your classic piecewise example.